Chapter 2: Electricity from the atmosphere applied to the roots of plants and to the soil surrounding them. In 1891, Pauline of the agricultural school at Beauvais, France, began a series of experiments near Montbrison with the expectation of drawing down the atmospheric electricity in more abundant quantities than had been done by previous experimenters. He erected what he called a geomagnifier, Geomagnetifier. It was merely a tall, resinous pole planted in the earth and carrying to its top a galvanized iron rod, insulated from it by porcelain knobs, and terminating in 5-point branches. The electricity thus collected from the atmosphere was carried to the soil and distributed by means of a system of underground wires to the area of ground to be electrically influenced. His first experiment was with potatoes. The part of the field under electric influence responded in a surprising manner, as is evidenced by the following extract from a newspaper reported at the time. The eye is arrested by a perceptible irregularity in the vegetation of the field. Within a circle limited exactly by the place occupied in the earth by the conducting wires of atmospheric electricity, the potato plants possess a vigor double that of the plants occupying the rest of the earth, and that too without a gap, without a feeble point in this group of superb stalks, sharply circumscribed as by a line drawn by a compass. According to the report of the committee delegated by the Montbrison Society of Agriculture to report on Pauline's experiments, a geomagnetifier 28 feet high made its influence felt over a radius of 65 feet, and the yield of potatoes within the electrified area was from 50% to 75% greater than without it. This committee was quite enthusiastic over the results of Pauline's experiments and awarded him a special medal. He next experimented with his geomagnetifier in a vineyard and found that grapes were much advanced in their growth and that they were much sweeter, yielding about 5% more sugar and less acid. This further experiment, he found that spinach and celery were markedly influenced, some leaves of the former reaching the length of 1 to 4 feet, 1/4 feet, and some stalks of a latter 3 feet. Radishes and turnips were much improved in size and quality, and sugar beets yielded a larger percentage of their saccharine compound. It was also noticed that potatoes and sugar beets electrically cultivated were singularly free from disease, while those outside of the influence were often seriously affected. Ch2 modified Pauline's experiment by sticking a number of poles into a field, each pole having a point at its apex, and all being connected with a system of underground conducting wires so as to distribute the electricity to the soil. By these means, he says, the electricity of the atmosphere is rendered denser over the field, and the plants develop in a field of high electric tension. After 5 years of experimentations, he was most favorably impressed with the results. He tells us that 475 pounds of rye by the ordinary method of cultivation grew 2,825 pounds of grains and 6,175 pounds of straw, while by the electric method, the same quantity of seed yielded 3,625 pounds of grain and 9,900 pounds of straw. Barley and wheat responded in a similar manner, while oats yielded even larger returns. This method of applying electricity to vegetation is a tempting one to pursue on account of the abundance of atmospheric electricity at one's command. In speculating on cosmical electricity, Professor Elihu Thompson says the Earth may possess the character of a huge conductor, the outer coating being the rarefied conducting air, the inner coating, the ground and water surface, and the dielectric, the dense air between. The electric potential on the top of the Eiffel Tower, 984 feet high, he says may be as great as 10,000 volts, and if we increase be 1,000 volts for every 100 feet on the average, it would rise to 1,000,000 volts at an altitude of 20 miles. So we may liken the Earth to a huge Leyden jar, the dense air acting like a non-conducting glass between the inner and outer metallic coatings of the jar. Sometimes in charging a Leyden jar, the electricity will break through the glass, especially it is apt to do so if the glass contains lead, and ruin the jar thereafter for experimental purposes. Likewise, sometimes electricity under such high potentials in the upper rare atmosphere, in storm clouds for instance, will break through the intervening denser air and discharge itself into the ground or water. This we call a stroke of lightning. Franklin raised his kite into such charged clouds, and their electricity came down the strings and filled his Leyden jar, proving the identity of the electricity of the atmosphere with that of the plate machines ordinarily used to charge Leyden jars. What if Pauline's geomagnetifiers could be made to penetrate miles up into the reservoirs of electricity and thus furnish an easy path for it to the Earth? It is interesting to speculate upon the possibility of our being able to tap this great storehouse of stimulus to vegetation, possibly even to human development, at will. If we ask whence the outer rare layers of our atmosphere get their electricity, we may come nearest a correct answer by saying from the sun, that great source of so many forms of energy. We know that displays of the aurora borealis and also electric storms, which are so unwelcome to telegraphers, are most frequent during the prevalence of sunspots, and we know that these spots are due to some great disturbance upon the sun. Whether the electricity thus generated upon the sun is carried to our upper atmosphere by minute particles thrown out by these eruptions, as is claimed by some, or whether we get it by induction across space, as is thought by others, we will not attempt to determine. We do know, however, that the electric potential does increase as we go up from the Earth's surface. According to Mr. McCaddy, it can be measured very accurately by means of this kite experiment, which bears some resemblance to Franklin's historic one of so many years previous. There is, however, a very marked difference between the conditions which surrounded these two experimenters when they sailed their kites into the skies. Franklin courted the anger of the thunder clouds and flew his kite with its pointed wire into the face of death, so far as he knew. His theory of the identity of electricity and lightning had not yet been proved. Possibly it would be proved at the expense of its originator's life. He knew that the electricity of the Leyden jar was deadly to small animals. Indeed, his own life had been shocked into insensibility by it. The ingenious Mr. McCaddy flew his kite into the blue of a cloudless sky and took note of the sparks discharged from the lower end of the insulated wire connected to it. By connecting an electrometer with the wire, He could usually tell whether the kite was raising or falling by readily the larger or smaller deflections of the needle. It may be a profit to consider, even if very briefly, in closing this chapter, the effects of atmospheric electricity upon man, whether or not it assists in his physical development and well-being. Jean-Paul Richter speaks of the value of the thunderstorm bath, reminding us how fresh, cheerful, and elastic we feel after a warm or tepid rain has penetrated to the skin, and how after being exposed to a thunderstorm and becoming dry, we are invigorated just as the flowers are when they stand erect and look refreshed after the passage of a storm. He says, why will they not receive this united fire and water baptism from above and suffer themselves to be raised and healed by the wonder-working arm in the thundercloud? He says, why will they not receive this united fire and water baptism from above and suffer themselves to be raised and healed by the wonder-working arm of the thundercloud? He is practical when he advises a special suit of clothes for this purpose, and the forming of rain parties when there is promise of wet weather in the warmer seasons. If we incline to Richter's belief, may we not reason that any form of dress which insulates us in a high degree from the earth and thus prevents the passage of the atmospheric electricity pass through our bodies is detrimental to us? This may furnish one of the reasons why one feels best when he is able to run barefooted. Also, it may explain why in some parts of Germany it is claimed that many diseases may be cured by simply connecting oneself with an iron rod driven into the earth. Possibly we may refer any good which may be derived from the numerous patent devices for electro-liberating, polarizing, etc., to the fact that they are merely contrivances of electrically connecting one with the earth, and have nothing inherent in themselves as a means of electrically influencing the body. If there perchance be any good in these high-priced and much advertised devices, the author would recommend as being just as efficacious, very possibly much more so than certainly much cheaper, the connecting of one's ankles by means of an insulated wire with gas or water mains, which have such good connections with the earth. If indeed atmospheric electricity benefits plants as it certainly does, may it not be of use also to the collection of living cells which go to make man's body? Possibly we think too lightly of this.